All right, so in this animation, we're going to be looking at the double slit experiment, the double slit interference patterns that are formed with waves, what patterns are formed and why. So it says the way of nature of light is beautifully revealed in double slit interference, light striking a barrier. So these are the incoming rays on the left-hand side. With two openings creates a set of spreading waves. The wave crests are shown in light gray, the wave troughs are shown in dark gray. So these brighter lines are considered to be the crests of the waves, and the dark lines are the troughs. As they come to the double slits, you can see there are these circular wave patterns that are moving outwards. It says down here that the neutral gray represents a zero amplitude. So if we come to the far end of this animation, you'll notice that there are the dark and light lines, which are quite clear, but then in between there are these grayish lines. That is the zero amplitude. The two spreading waves will interfere. Note that there are regions where crests meet troughs and exhibit destructive interference. So that would be along these gray lines. This is where we have our destructive interference. They cancel out each other, leaving no wave motion. These regions are called nodes, and again, it's the neutral gray, which are in these areas right here. So if we were to introduce a screen on the right-hand side, this shows the pattern of bright, dark, bright, dark, bright, dark. It's a repeating pattern. The bright is where we have constructive interference. The dark is where there is destructive interference. So in the middle they call this the central maxima. So that is where there's maximum brightness. The first dark spot is called a minima. Then the next maxima is called maxima m plus 1. Then there's another minimum, then there's another maxima. So they're basically labeling them. The central one is given no number, but then as we move upwards, you'll see that it's the first maxima, the second maxima, the third, and same thing as we go down. So as constructive regions where there is wave motion will light up the screen, shown in white. These are called the maxima. Destructive regions where there are nodes leave the screen dark, shown in black. These are called the minima. So the waves travel the same distance to the central maximum, so the waves always arrive in phase, resulting in constructive interference. So they're showing you a transverse wave coming from the top and the bottom slit, and the patterns reach the screen, and they're showing with a little magnifying glass that the wave coming from the bottom and the wave coming from the top are in phase, which means the crests are lined up with each other, as are the troughs. This is by definition constructive interference. Constructive interference means brightness. If we move up slightly in the pattern, what we'll notice is the bottom ray actually has to travel a slightly further distance, and what that means is when they reach the screen, it's the crest of the top wave interfering with the trough of the bottom wave. So these are 100% out of phase, and this is destructive interference. So it says the first minima is caused by destructive interference. As we move further up, again, the bottom ray happens to be longer. There's more wavelengths packed in. But in this case, what happens is the crests and troughs are both lining up again from the top ray and the bottom ray, and we get constructive interference. Moving up to the next minima, again, the bottom ray is longer, and in this case, it happens to be a length such that it is now out of phase. So the bottom wave is 100% out of phase with the top. So it's the trough of the bottom wave interfering with the crest from the top wave, which cancels out, and we have destructive interference again. And the pattern continues as we move up, and because it's symmetrical, obviously we have the same thing below. So constructive, destructive, constructive, destructive. So we're going to take a look at this now from the other end, which is close to where the slits are. It says the waves travel the same distance to the central maxima, so the waves arrive in phase, resulting in constructive interference. This is for the central maxima. So now as we move up to the first minima, they're showing you there's a wedge of a triangle, and what they're basically trying to show us is the bottom wave is now 1/2 wavelength longer because it has to travel a further distance. Because we have added that 1/2 wavelength, when we get to the screen, it is now out of phase with the top wave. So at the first minima, there's an extra half wave in the bottom path. The lower path is out of phase with the upper path, resulting in destructive interference. So now we'll slide it up back to constructive interference, and if we look at the way this is set up on the bottom here, the bottom wave is actually one full wavelength longer. So if it's one full wavelength longer, that actually means that the lower path is in phase with the upper path, resulting in constructive interference. So we've added a full wavelength, which means when we get to the screen up here, the crests and troughs of both waves are now in line again. Moving up to the next minima, and we can see on the bottom that we have added another half of a wavelength. So now the bottom wavelength is actually 1.5 wavelengths, or 3/2 wavelengths. What that means is when we get to the screen, the bottom is now going to be out of phase with the top. At the second minima, there is 1.5 extra waves in the lower path. The lower path is out of phase with the upper path, resulting in destructive interference or a dark spot on the screen. And we'll move up to the next maxima, and we can look on the pattern down here. So we have added 2 full wavelengths. By adding 2 full wavelengths, the lower path is in phase with the upper path, resulting in constructive interference. So that's how we're getting these bright spots and dark spots. It's essentially the difference in length between these paths and how they interfere when they hit the screen.